Welcome back to Deltaplex Live, the real-time enterprise show. I'm Alex.
And I'm Maya. And today, we're coming back to one of the biggest questions in enterprise AI right now. Not just can we build an AI agent, but can we actually give that agent the right business context to act safely?
Exactly. Today's episode is called Preparing Operational Data for AI Agents. And I think this topic is important because a lot of companies are moving past the demo phase now. The first wave was, let's build a chatbot, let's connect it to a few documents, let's see if it can answer questions.
Right. That was the easy part.
Yeah, but now enterprises are asking, okay, can an agent help with fraud review? Can it route customer service cases? Can it monitor inventory exceptions? Can it support risk teams? Can it help operations move faster? And once you ask those questions, the data problem gets much more serious.
Exactly, because an AI agent that operates inside a live business process cannot rely on yesterday's reporting snapshot. It needs to understand what is happening now. Orders change, payments move, inventory updates, shipments get delayed, customer records change, risk signals appear. And if the agent does not see those changes in time, well, it may still give an answer, but the answer may be based on the wrong version of the business.
Let's start there. For years, enterprises have had dashboards, reports, data warehouses, BI tools, all of that. So why do AI agents raise the bar?
Because traditional analytics is mostly passive. A report tells you what happened. A dashboard shows trends. Even if the data is, a few hours late, it can still be useful for planning or management review. But agents are different. They're designed to observe, reason, recommend, and sometimes take action inside operational workflows.
So the decision window is shorter.
Exactly. Let's say a customer service agent is helping a customer with an order issue. It may need the latest order status, payment status, shipment status, inventory availability, account state, and support history. If it sees stale data, it may say, your order's on the way, when actually the order was canceled 10 minutes ago.
And from the customer's perspective, that's not a data issue, that's just a bad experience.
Right. The customer does not care that the pipeline refreshed late. They just know the answer was wrong. And in areas like fraud, risk, compliance, or operations, stale context is even more dangerous. An agent can sound confident but still be acting on incomplete reality.
So the model may be smart, but the context is weak.
Exactly, and that is the key point. AI agents are only as useful as the operational context they can access.
Let's talk about the current enterprise environment. Most companies already have data pipelines, so where does the gap come from?
A lot of enterprise pipelines were built for reporting, not for agentic workflows. Many still run hourly, daily, or overnight. That might be fine for a finance report or a monthly management dashboard, but it's often too slow for an agent making decisions inside a live process.
So if the data arrives late, the agent is basically looking at a business that no longer exists.
Yes, that's a good way to put it. The second issue is fragmentation. Operational data is spread across core databases, SaaS applications, event streams, legacy systems, and internal workflows. And an agent rarely needs just one system.
Right, it's not like, hey, just check the CRM and you're done.
Exactly. A fraud review workflow may need transaction data, account history, device signals, customer behavior, and risk scores. A customer service workflow may need orders, payments, shipping, inventory, SLA commitments, and previous tickets. If each workflow needs custom integration logic, things become hard to scale very quickly.
And hard to govern.
Very hard to govern because now every agent may have its own custom data path, different connectors, different logic, different access rules, different monitoring. That is manageable for a pilot. It is not a good foundation for production AI.
There's another shortcut that looks tempting in demos. Just let the agent query the production system directly.
Yeah, and to be fair, for a demo, that can work. You connect an agent to a database or API, ask a question, get an answer. It feels very impressive. But at enterprise scale, it creates risk.
Because now the agent is adding load to systems that are already running the business.
Exactly. Think about hundreds or thousands of agent actions happening at the same time. Each one may query a production database, call an API, or request data from a critical application. That can create unpredictable pressure on systems that handle orders, payments, accounts, claims, trading, logistics, whatever the core business depends on.
So the agent may be helpful, but it may also become a new source of operational risk.
Right. And that is why non-intrusive data capture matters. Instead of repeatedly querying source tables, enterprises need a way to capture changes as they happen with lower impact on the source system.
This is where CDC comes in.
Exactly. Change data capture. In simple terms, CDC reads committed changes from database logs. So rather than asking the database every few minutes, hey, what changed? What changed? What changed?
Which is kind of annoying.
Very annoying. CDC listens for committed changes and delivers them downstream. That helps keep data fresh while reducing the load on mission-critical systems.
Okay, so let's turn this into a checklist. If an enterprise wants production-grade AI agents, what does the data layer need to provide?
I'd say 6 things. First, low latency movement. Not every workflow needs milliseconds, but the data has to arrive within the decision window. If the agent needs to act in minutes, then a 6-hour data delay is not acceptable.
Second,
Third, unified context. The agent needs a consistent view across the relevant operational systems. It should not have to stitch together 5 unreliable fragments every time it acts. Third, non-intrusive capture. Fresh data should not come at the cost of overloading production databases. Fourth, schema resilience. Source systems change, tables change, fields change, data types change. The data pipeline needs to detect and manage those changes before agent behavior silently breaks.
that silently breaks part is important.
Very important. A visible failure is bad, but a quiet data quality issue that causes the agent to make bad decisions, that's worse. Fifth, governance by design. Lineage, audit logs, access controls, masking rules, those cannot be an afterthought. And sixth, operational observability. Teams need to monitor freshness, latency, errors, throughput, and downstream delivery.
So in plain language, the agent needs fresh data, complete context, protected source systems, strong governance, and visibility when something goes wrong.
Exactly. That's the foundation.
Let's describe what that foundation looks like, not in a super technical way, but as a practical architecture pattern.
Sure. At the bottom, you have operational systems. These are the places where the business actually happens: databases, SaaS applications, event streams, and legacy platforms.
Then you have a non-intrusive capture layer. That can include CDC, event capture, or controlled replication.
So this layer captures what is changing without constantly hammering the source systems.
Exactly. Then comes the governed delivery layer. This is where schema handling, lineage, access control, monitoring, and delivery rules come in. After that, you have the AI context layer. Depending on the use case, that could be a feature store, vector database, lakehouse, real-time store, or some combination. And then the agents sit on top.
Right. Agentic workflows like fraud review, customer service routing, inventory optimization, risk monitoring, or compliance review.
So the goal is not to connect every agent directly to every system.
Exactly. That's the trap. The better pattern is to build a governed operational context layer, one that gives agents trusted, current, traceable context without compromising the systems that run the business.
Let's make this real with a few use cases. Start with fraud and risk review.
Fraud and risk agents need current transaction data, account history, customer behavior, device signals, and risk scores. If that data is fresh and traceable, the agent can help reduce blind spots and improve decision traceability. But if the data is late or fragmented, the agent may miss important signals.
And then you're not really preventing risk, you're reacting after the fact.
Exactly. Second, customer service routing. A service agent may need order status, account state, payment records, SLA commitments, and support history. With fresh context, it can route cases more accurately and reduce manual investigation.
Which is huge because support teams spend so much time just checking systems.
Exactly. A lot of manual work is really just context gathering. Third, inventory and operations optimization. An agent may need sales, inventory, supplier updates, shipment events, and warehouse activity. If it sees changes quickly, it can help adjust stock levels, flag exceptions, or recommend replenishment faster.
And compliance?
Compliance and audit workflows need lineage, policy checks, movement logs, and exception records. When AI is involved, transparency becomes even more important. The enterprise needs to explain what data the agent used, where it came from, and what happened afterward.
Let's bring Deltaplex into the discussion. How does Deltaplex help enterprises prepare operational data for AI agents?
Deltaplex helps turn operational data into a governed, real-time context layer. First, it supports log-based CDC, so enterprises can capture committed changes from source systems without repeatedly querying production tables. That helps deliver fresh data while reducing impact on mission-critical systems.
So freshness and source system protection at the same time.
Exactly. Second, Deltaplex connects across operational environments, databases, applications, event streams, and legacy systems. And it delivers data into downstream environments, like data warehouses, lakehouses, real-time stores, vector searches, and AI platforms.
Which matters because different agents need different kinds of context.
Right. Some need structured real-time data, some need historical context, some need vector search, some need all of the above. Deltaplex also supports schema change detection and handling, which helps downstream consumers adapt when source systems evolve. And on governance, it supports lineage, metadata capture, audit visibility, and access controls across data flows.
Deployment is also part of the story, right?
Yes, Deltaplex can be deployed on-premises, in a VPC, or in hybrid environments. That gives enterprises more control over sensitive operational data, data residency requirements, and infrastructure governance.
This can sound like a big transformation, so how should a company actually start?
Start narrow. Pick one high-value agent workflow where fresh operational context clearly affects business value. Don't start with, let's connect everything. Start with which agent workflow really needs better context.
Like fraud review, customer service, inventory exceptions, or compliance monitoring.
Exactly. Then map the required context. Usually you identify the 3 to 5 systems the agent must understand to make a reliable decision. After that, build the context layer for that specific workflow, move operational changes into the selected environment, and validate latency, completeness, schema handling, and source system impact.
And governance before scaling.
Yes, always. Configure access controls, masking rules, lineage capture, and audit logging before the workflow becomes production critical. Then expand incrementally, add more sources and more agent use cases after the first workflow proves value.
Let's turn that into a 90-day action plan. What should happen in the first 30 days?
Days 1 to 30, assess agent data readiness. Choose the priority use case, map the source systems, measure the current latency baseline, identify governance requirements. Basically, understand what the agent needs and where the gaps are.
Then days 31 to 60.
Build the pilot context layer, set up CDC pipelines, deliver the initial data, add monitoring, configure access controls, validate freshness, completeness, and delivery.
And days 61 to 90.
Prepare for production rollout, create a runbook, define ownership, confirm success metrics, build the expansion roadmap, and do an executive review.
So by day 90, the company should know whether this agent workflow is ready to move toward production.
Exactly. And more importantly, they should have a repeatable pattern for the next workflow.
So the big takeaway from today's episode is this: AI agents do not become production ready just because the model is powerful. They become production ready when the data foundation is ready.
Exactly. Agents need fresh, unified, governed, and reliable operational context. Without that, they may amplify the same problems enterprises are trying to solve: stale data, fragmented systems, unclear ownership, and weak governance.
And the answer is not to connect every agent directly to every system.
Right. That may work in a demo, but it is risky in production. The better path is to build a governed operational context layer, one that delivers fresh, trusted data without compromising source systems.
Start with one high-value workflow, prove the value, govern it from day one, then scale.
Because at the end of the day, AI agents are only as good as the context they are working with.
Well said. Thanks for joining us for Episode 5 of Deltaplex Live, the real-time enterprise show. I'm Alex.
And I'm Maya. In the next episode, we'll continue exploring how real-time data infrastructure supports enterprise AI, analytics, and operational transformation.
Thanks for listening, and we'll see you next time.